I have a child class child 2 extends parent. I'm just overriding the method from the parent class to child 2 class also. System.out.println of child 2 print. Class manager 2. Inside class manager 2, I will take main method. Here, I'll take reference of parent. I'm not creating object to the parent class. The reference I will refer to the parent equal to new child 1. I'm creating object to the child 1 class. Object is created into the memory. That object I am referring using the parent class reference. Whenever we are referring that, whenever we are creating object to the child class, whatever members are there inside the child class, all the non-static members will load into the object. We have only one non-static method. That method is a print method. We will get one more print method, void print. It is overridden into the parent class. But in child 1 class, we are just overriding the print method of parent into the different print method. We are just changing the body of the print method from the parent class overridden one in the child 1 class. So whenever we create object to the child 1 class, but that object is referring using the parent class reference. Still, if you call parent.print method, we'll get output of child 1 class print method output. Why? Because object is created in the memory for the child 1 class. First, whenever object is created, whatever parent superclass methods are there, first it will go and sit into the memory object location. After that, the whatever method is there for parent, this is we override it using the new method, same method. So whatever parent class print method is there, that is overridden with the new body of the child class print method. Now whenever we call this object print method, we will get the output of child 1 print method. Because the object is created for the child 1, so we will get the output of child 1 print method. Now, for the same reference, I am creating object to the child 2. Print parent.print. Now inside the memory, object is created for the child 2. The object already created for the child 1, that object is pointing using the parent reference. Whenever we are getting object to the new child 2, object is created in the child 2 in the memory. Inside the object, whatever members are there in the child 2, those members will go into the memory. Now whenever we are calling using the object reference to the this print child 2 print method, it will go and execute this method. Here, the reference, same reference, whatever parent reference is there, the same reference I am pointing to the child 2. Now, whatever this reference is there for child 1, now that reference is removing from the memory, this parent reference, that parent reference will go on pointing with the new child2 object. Now whenever we call using the parent.print method, we'll get the output of child2 print method. Now this is all about the memory reference. Now if object is created, right hand side new child1 is object is created in the memory. That object is pointing with the reference of parent. Now if you create object of new child1, here new object, then whatever existing object is there, that existing object reference will go now child2. I created two objects. This is the first object, new child1, this is the second object. Now first object is referring with the parent reference. Now whenever Java command is executing this line, here second object is created, second object is referring with the reference of parent. Now this object reference is removed from the memory, then it will go and refer with the parent of second object, because whenever we are executing this code will execute from top to bottom. First this line will execute, after this line will execute. Whenever this line is executed, parent reference is referring with the child1 object 1, and we are calling the parent of print method. It will go and execute the child1 method. Then whenever executing this line, child1 object 2 is created, that object is referring using the same reference parent. Now we cannot access this member, child1 object 1 we can't access. Now this reference is referring using the this reference, so we can access only these members. After this, it will come and execute this line. Whenever it is executing this line, child2 object is created, that object is referring using the parent reference. Now parent reference is not referring to the all these objects, parent reference is referring to the child2. Now parent dot print method, whenever you execute this, we'll get output of this. Now we get output of child1 and we'll get output of child2 print method. So here we are calling same method, parent of print. Here method is same, here also method is same. Same method will give the different output. This is called polymorphism. This is runtime polymorphism. This is happening in case of compile time, because this is static members. Whenever compiling only, polymorphism is happening. Same method will give different output there. But here, this is happening while running the program. Here runtime. Now object is referring using the reference of parent. After this line, this is just printing the child1. After executing this, then it will come and execute this. Whenever it is running this line, runtime, so it is converting the reference is pointing with the child2, and we are calling the child2 object method, print method. So we can call this as a runtime polymorphism. Here we have to remember, to achieve the runtime polymorphism, how to achieve the runtime polymorphism? We can achieve it using the overriding. Here we are just overriding the method, print method from parent class to subclass. How to achieve the compile time polymorphism or static polymorphism? By using overloading, we can achieve static polymorphism. You go and see this example. Here, this is just overloading. Same method with a different signature. Now, what is overloading? In a class, we have same method name. Same method name for multiple methods, but the signature of the methods are different. Called overloading. What is the signature? Signature of the method is depending on type of the arguments, number of the arguments, order of the arguments of a method. Signature of the method is depending on type of the arguments, number of the arguments, and order of the arguments. This is overloading. What is overriding? Runtime polymorphism we can achieve using the overriding. Inherits the definition from superclass to subclass. It's called overriding. Just inherits method definition from superclass to subclass is called overriding. If you not remember the definitions, you can take one example, you can explain. We have a class, superclass, and we have a class, subclass, extend superclass. Here, inside a subclass, the methods of a superclass are overridden. This is overloading and overriding. Now we have seen the what is polymorphism. Now we can see what is encapsulation. Combination of data hiding and abstraction is called encapsulation. The combination of data hiding and abstraction is called encapsulation. I'll take one example. Our class person inside person class. I have three private members, private attributes. I have all getter methods, public, similarly, to setting the data to the name and age and the qualification attributes, we have setter methods. Start age equal to age. We are just setting the values into the current class attributes. Public void. Return type is void, so we no need to return anything. Argument I am taking as a string qualification. This start, I am storing the value into the current class attribute from the local variable of set qualification method. Now here, what is data hiding here? Inside a person class, if you want to achieve encapsulation, We have to declare all the attributes of a class as a private. How to achieve encapsulation? To achieve encapsulation, you can declare all attributes of a class are private. Now here what is a private? By private members, we can access within the class. We cannot access the private members outside the class. By making the attributes of a person class as a private, we are just hiding the data. Nobody can access person class private attributes outside of the any other class and outside any other class anywhere of the if you create a subclass to person class, we cannot access the private members. If you want to access the private members of a person class in the same class in the same package, you cannot access. We can access the private members within the same class. So we can tell by declaring the private attributes in the person class, we are just hiding the data. To achieve the encapsulation, we can declare all attributes of a class are private, and we can create public getter methods for each attribute to read the data. To achieve encapsulation, we can declare all attributes of a class are private, and we can create public getter methods for each attribute to read the data. We can create public setter methods for each attribute to write the data. Here, by using getter methods, get name, get age, and get qualification. If you create object to the person class, by using person class identity reference, object reference, we can access the name of the person class by calling get name. We can access the age of the person by calling get age. We can access the qualification of the person by calling get qualification. This is for reading the data of a person class. How to write the data to the person class? Here we don't have any constructor, no argumented constructor. By default, we'll get the no argument constructor. Even though if you create object to the no argument constructor, how to set the data to the person class outside this person class? We cannot set the data to the person class outside the class because all attributes are private. So we are just providing the setter methods, all public setter methods. We create public setter methods for each attribute to write the data of a person class. If you want to write the data to the name attribute, this dot name equal to name. By calling set name method, you can set the data. By calling set age method, you can set the age of the person class attribute. By calling set qualification, we can set the qualification attribute data to a person class object. What is the advantage of encapsulation? What is the advantage? What is the advantages of encapsulation? We have flexibility to give read only or write only option. So our class or data. Now if you want to just give option to only read the data, we can give only the getter methods. We are not giving any setter methods. If you want to give option only for writing the data, just create only setter methods, don't create any getter methods. Second one is, no one can directly access attributes of a encapsulated class. Here, if you have this, we have this person class attributes, string name, int age, string qualification. Nobody can access these attributes directly by creating object. They have to call the getter methods to get the data, or they have to call the setter methods to set the data. Yeah, that's all from today. For today, you can see in the next class, tomorrow class.